I guess we should start. Hello everyone, I am Marina and I will be a tech support during this tutorial. I want to introduce you to our tutor Jakob Triva. He is a consultant at Poslovna Inteligencija or Business Intelligence, and he will hold the molecule testing and Ansible-Driven data lake deployments on Kubernetes tutorial, so enjoy.
Yeah, so, okay. Hello everyone. As she said, my name is Jakob Triva, and I work as a data engineer at Poslovna Inteligencija. And today I'm going to introduce you to Molecule and demonstrate how we used it for both manual and automated testing of Ansible-driven data lake deployment. So this is a table of contents. Firstly, I'll say something about my employer, Poslovna Inteligencija, a bit about the project Cyber for Defense, our module inside the project, and something about the technologies we will learn to use today, and those being Ansible, Vagrant, and Molecule. And after that, we will, of course, have a tech tutorial. So Poslovna, so who are we? Poslovna Inteligencija is a leading ICT consulting company in Southeastern Europe. We nurture strong partnerships with all the leading technology vendors, and we are technology agnostic. And we have over 20 years of experience in the largest data and analytics, performance management, data migration, data engineering, and machine learning projects. We have around 200 employees that are primarily located in Zagreb, but we also operate from offices in London, Vienna, Stockholm, and so on. From last year, actually, we also have an office in Osijek, from where I'm from, and I'm currently presenting from there. So, yeah. So, Cyber for Defense project is project funded by the European Union, and it stands for Cyber Rapid Response Toolbox for Defense Use. And the idea behind this project was to, as it's stated by this quote here, to develop an easily deployable, modular, and scalable cyber rapid response toolbox to manage cyber incidents in different complex national and international scenarios, where the main target being that it's easily deployable. It's where we used actually Ansible, and it's the code that we are testing today with Molecule. So our module inside that project is a data science module. It so this is basically the design of our module. It has two different sites, being back office and workplace site. On the back office, we have services set up like Elasticsearch, JupyterHub, Spark, Airflow, Kibana. Entity linking is actually an application. It's also our module within Cyber for Defense, and but I wasn't a part of that module. But it's deployed also on Kubernetes, and our services integrate with it. And on the workplace module, we have let's say a mission that is deployable, and that can have multiple sensors where multiple data collection modules are located, and where our file bit instances are collecting that data, processing it using file bit configuration and Elasticsearch ingest pipelines into the Elasticsearch. The main thing here is that all data on all missions, on all sensors should be readable from the back office. For that functionality, we use cross-cluster search. Cross-cluster search basically allows you to read data from one Elasticsearch to all other remote cluster search. and we use Airflow for data replication. We have cross cluster replication set up using Airflow and replication, basic data replication. So something about Ansible. I guess some or most of you are familiar with Ansible. So it's an open source automation tool with some of its key features being that it's agentless, which means that the tool can communicate with and manage remote machines without the need for any additional agent being installed on the remote machines. It facilitates the use of declarative languages, so all specifications or Ansible playbooks, roles, even inventory file, although inventory file can be in any format also, YAML format is used. And idempotence, so idempotence is one of the main principles of Ansible. It guarantees a consistent and reliable automation process. What basically means what basically idempotence is in Ansible context is that when you run Ansible playbook or role multiple times, you should expect the same configuration on the remote machine. Some of the use cases for Ansible is it's mostly used for some infrastructure as code solutions, application deployments, and task automation. So something about Vagrant. Vagrant is an open source tool, also open source, for building and managing virtualized development environments. It provides a command line interface to manage virtualized environments with ease. And we can see here a list of those basic commands being Vagrant init, Vagrant up, global status SSH and destroy. So we use Vagrant init to initialize what is called a Vagrant file. It's a file where the configuration for your remote machines that you want to provision is specified. You would basically use it as is because it just initializes a plain text file. You can specify a box that you would like to use. So Vagrant box is essentially what Docker image is in context of Docker. Vagrant box is basically that in the context of Vagrant. So you would say Vagrant init and the box name, but you can also edit that later in that generated Vagrant file. Vagrant app creates and provisions that new virtual machine, remote machine. Vagrant global status basically writes current state of all running and stopped remote machines. Vagrant SSH allows you to connect to your machine via SSH, and Vagrant destroys the provisioned machine. And you can also extend functionality of Vagrant with multiple plugins. For example, if you want to integrate Vagrant with VMware, it's not supported out of the box, so you would need to install a plugin for that. Oh, sorry. And last but not least, Molecule. That's why we are here today. It's a testing framework for Ansible roles and playbooks, with some of its key features being scalable testing that allows you to test your roles and playbooks at scale across multiple scenarios, versatile platforms, so you can use Molecule with various platforms like Docker, Vagrant, which we will see later today, and for example, Podman and stuff like that. And idempotent testing, it ensures consistent results with idempotent testing. It basically out of the box tests idempotence of your Ansible playbooks. Okay, so it's time for a demo or a workshop. So let's get to the Visual Studio Code. Can you see this? Is this like? Is this okay for you?
Yeah, we can see everything.
Okay. So we have two demos that you can also try on your local machines. For those of you who have Windows installed, so you can Molecule natively supports only Linux. It doesn't support Windows, but you can use it using VSL. It runs beautifully with Docker and Docker desktop, but you also need to enable VSL integration in your Docker desktop. With Vagrant, it's a bit different. I mean, it technically could be done, and I've successfully provisioned some instances with Vagrant, but it's painfully slow, and you would need to extend all possible I don't have a word. All possible. I don't have a word. Sorry. So I will share with you a Docker repo where you can find those two demos, so we can download it, clone it to your local machines, and try if you want. It's over here. I'm not used to. Where should I? Is there a chat or something? Oh, get it. Okay. Oh, you already shared it. Okay, so you can see in webinar chat there is a link to my Docker repository, so you can download those two demos. But we will go through them here. So whatever you like. Okay. So firstly, we'll start with Docker demo. Here we can see folder structure. So basically, when using Ansible, there are multiple Docker structures that are okay. We went with inventories where we have multiple subfolder structures for each environment. Here we have only tests because obviously we are not using this demo in production. Where you can see group vars and host vars. So if you're familiar with Ansible, you would know what it means. Basically, you're specifying a host file when running Ansible. You're specifying a host file where you have a list of your hosts, and each of those hosts can be a part of some group. So, for example, in context of Kubernetes, we have groups: Kubernetes masters, Kubernetes workers. Each of that group has a list of hosts with each own IP address, maybe Ansible user, SSH port, and configuration like that. So when creating variable files, var files, you can structure those files in this way, so it's easily editable. So, for example, here we have hosts vars subfolder called test instance 1. That means that when you run an Ansible playbook on a host that's whose name is test instance 1, these var files are going to be included. Same goes with group vars. You can specify a YAML file for let's say this is a group Docker test 1. And you would include these variables in all hosts that are part of that group. Okay, so playbooks. It's just basic playbooks where we include roles in playbook Elasticsearch. We include role Elasticsearch in Kibana. And then we have our roles. This is a basic folder structure for roles. So we have a role name. Inside of those, you have subfolders, tasks, templates. There are plenty of them. For example, vars for variable files, files for files, vars for variable files, templates for Jinja templates, tasks where you specify your Ansible tasks. And here we can see a folder called molecule. So this is what's interesting to us. It's where we initialize our testing scenarios. Default is default test scenario. And this is a folder structure that we get when we actually, so when you initialize a molecule scenario with the molecule init, so when you go molecule init, it would initialize a molecule scenario with name default, but we already have a default scenario, so we would provide the scenario name. So it's a flag -s and scenario name my scenario, for example. Sorry, molecule. And we can see our new scenario initialized. It creates these files: converge, create, destroy, molecule, and verify. On today's demo, we don't need those two files, create and destroy. So basically, you would specify your setup for creating and destroying molecule instances. But as for in our demos, it's automatically managed by molecule. We don't need this. What we are left with is converge, where we specify our Ansible tasks that are going to be ran. Molecule is where we define our instances, our inventory, and stuff like that. Our test plan, and verify is where we specify our assertions, our tests. But as we there are some other configurations that can be added, like prepare. There are some others, but yeah, we'll see that later. As we have initialized already initialized scenario, we will go through that. So molecule.yaml is where you define your instances. So you define your driver. So currently we are using Docker for a driver. In platforms, we defined one instance called test instance 1, and as we can see here, it's the same name as the host vars folder. We are using this image because it has everything that we need for today's demo. There are some flags. So this configuration is provider specific. So for Docker, it's not the same as for example, for Vagrant. And if you would like to see how Vagrant looks like, but more of that later. They have their whole specification on their Git repository. I will also paste that to chat. So yeah, and here are some other stuff configured, like links to our group and host vars folders. Well, this is interesting. So there is a thing called Ansible vaults in Ansible. I don't know if you're familiar with it. So you can create a vault with Ansible vault create, I think. Yeah, create. And you specify the vault location. Let's put that in inventories, host vars, test, host vars. Let's say, okay, so this is what I already played with it today. Say vault2, it would prompt you for a new password. Let's say confirm that password, and it would open Vim. So you can write your variables that would later be encrypted and not readable. So let's say pass. Three. We need to exit Vim now. Oh. And it created a new vault here named vault2. So to when you run your Ansible code with the Ansible playbook, etc., you would get a prompt back, and you would put your vault password in there or do something else. No, but for testing purposes, you can also do this. So you can create a vault password file that is text file, text readable file. So of course it wouldn't be your vault on test environment shouldn't have any passwords that's or information that is compromising. So you can specify it like this, and when you run molecule tests, it would automatically have access to those vault variables. So to see what we have in that vault, we use Ansible vault view command. Ansible. From, and we have Elasticsearch user, Elasticsearch password, and Kibana password store here. Okay, so that's what we have in molecule.yaml. Then we have a converge YAML. In here, we just include Elasticsearch role. It's the role we are going to test, and it would automatically run main.yaml task. Then we have a verify YAML script where we write our own tests. So, for example, in here to test Elasticsearch health, we just simply send a request to the localhost 9200 with Elasticsearch password and user that are stored in our vault, and then assert if cluster status is green and response status is 200. So to test it, we go molecule test. And it will go through the test plan. So you can see these lines that they tell you what step is currently happening. So dependency test, lint test, cleanup test, destroy test. So, and for each of those test steps, you can define a YAML file, YAML configuration file, and edit it by your needs. By default, it runs a cleanup and destroy before creating new instances, and then it creates. Okay, so destroy, syntax check, and then create. Now here it creates a Docker container. We can see that with Docker container ls, and we can see that the Docker container is provisioned with our image. You can also do some port forwarding there and stuff like that. Then the prepare script is ran. So we didn't specify prepare script. What prepare script actually is, it prepares your environment. So if you so it sets up your environment to the point that what you would expect the server on the production, let's say, server is going to be. So, for example, if you expect for Docker to be installed, for Docker network to be present on the remote machine before you run your Ansible code, you can emulate that environment here with a prepare script. We will see that later, what kinds of things you can do there. Okay, so these are the tasks from our Elasticsearch roles. It sets base URL, so it's just a set fact. We can go through Ansible code. It's basic Ansible code. So for this demo, I just went with download Elasticsearch and unpack it and run it with bin Elasticsearch. I mean, nothing special. So it runs our Converge. It's running default Converge. Then it runs idempotence check. Idempotence check is what we talked about earlier. So basically what it does, it runs the Converge script again, and it checks if there are some changes. If all tasks pass with OK or skipped, basically the idempotence test is passed and everything is OK. Then there are some other steps like side effect. We can see here skipping side effect playbook not configured. So playbook would also be here named side effect.yaml. And it runs our verify playbook where we specify our tests, and we can see that all assertions passed. So our Elasticsearch cluster status is green. After that, it goes to cleanup and it destroys the instance. So when we go Docker container ls, that container should not be here, as it isn't. Okay, so we have also Kibana role. It's mostly the same as the Elasticsearch role, except it includes two Ansible roles, Elasticsearch and Kibana. We have also the same instance, but here we have a prepare script. So this is the first example where we have a prepare script. Let's say, I mean, as I said, this isn't a production grade content right here, but I need unzip package, and I would expect it to be there before I install Kibana. So I can put that in my prepare script to install unzip, and then I have unzipped up ready for unzipping Kibana zip and running it. Okay, I won't run Kibana test because we are short with time, as I would like to go through Vagrant demo and our data science module demo. So before going through Vagrant demo, I would like to show you how Vagrant works. So as I stated before, there are multiple basic Vagrant commands, like Vagrant global status. So it shows you all provisioned, all Vagrant provisioned and managed virtual machines. With Vagrant in it, we initialize a Vagrant file. Okay, here Vagrant file already exists. And in here, this is a box I was talking about. This is the only configuration you need to specify, basically. And we are using HashiCorp Bionic 46 image for our Vagrant test. To provision our Vagrant virtual machine, we just go Vagrant up, and we need to specify provider which we are using, in our case being VirtualBox. And with that said, it just provisions our virtual machine. It should be fairly easy, fairly fast. Okay, so the default SSH username for Vagrant machines is Vagrant. It uses hosts ports for connecting to the machine. From what I've seen, it uses firstly port 2222, then 2200, then 2201, and etc. And that can be useful to us for what we will later see. So when we now go Vagrant global status, we can see that our virtual machine is provisioned. We can SSH to that virtual machine with Vagrant SSH, and we need to provide that command with our instance ID, and we are up and running. So to destroy that provisioned machine, we just go Vagrant destroy and machines ID. Okay, so let's go to our demo Vagrant. So for those of you who want a hands-on experience, you can try this demo on your VSL, but as I said, it's fairly slow. Okay. So here, instead of initializing molecule scenarios within the roles, we initialize the molecule scenario on the project level with that's named Kubernetes deployment, because for any of these roles or services to function, all the roles need to be included. And this is our folder structure. We can see familiar Ansible playbooks: converge, molecule, prepare, and verify. I will just so to specify a scenario name when going molecule test, you can specify it with flag -s and scenario name. And there is a nifty flag called destroy never. So it's not going to destroy our instances, and with some port forwarding or something, you can play around and see, do some manual testing, see if everything is up and running you would like to be. So here we forwarded port 30 and 350. This is a port that's used in Kubernetes for Kubernetes ingress controller. So we can access our Kubernetes cluster from outside. So here we can see our Vagrant configuration. We are specifying that the driver name is Vagrant and the provider is VirtualBox. So what molecule here actually does is it creates those Vagrant files that we saw earlier and provisions those machines. We are creating a private network, and with this flag VirtualBox intnet, we are specifying that it's going to be internal network for Vagrant. But there is a problem with this, because when Vagrant provisions virtual machine, the default network interface is the same. And when you try access those IP address between them, let's say, so if you try to access this IP address from this virtual machine, it wouldn't work because it would go through wrong interface. So what I did here, for example, in prepare script, I routed all the network connections to this subnet, which is the subnet used in here to go through the IP it should be, through the interface it should go through, so that we can have connection between our master and worker nodes. So there are some other things here in prepare script. You can see it and play around it with yourself. In production, we use DFS, and to imitate that behavior, we are here for testing purposes using an NFS server. So we are serving that NFS server on a Kubernetes master primary, and then mounting that NFS server on our other nodes. So while this script is running, are there any questions? Do you want to ask me something, or? Okay, so still going through prepare script. Currently, we are installing Python dependencies. So we can see our Vagrant machines that are up and running now with global status. We can see that we created one master and the worker nodes. And if we check for our for our ports on our host machine, we can see that ports 2222, 2200, 2201 are used. So what we actually could do, and what I've done with it for our testing purposes, is you can create a host file, Ansible host file, with let me show you how that looks like. Which looks like this, where you specify Ansible user, Ansible SSH port, all the groups. So these are the groups that I was talking about earlier. For example, here, Kubernetes master primary, replicas. So you can have multiple groups for each host and so on. So we created we created this host file, and what you could actually do then is call Ansible playbooks, like Ansible playbook minus inventory file, blah blah blah. And so there was a requirement for us to have our mission deployment part done in a way that we call a script, a bash script. So this was a good thing for testing that that script. That script basically calls Ansible, runs Ansible playbook like this. We are currently going with CI/CD. We are not going with shell scripts for deploying missions. But yeah, so here we call Ansible playbook with inventory files and environment variables and stuff like that. And to test that script, it has shown that that was a really good feature. So it really takes a long time to get this up and running. Maybe I should have shown you I mean, I will show you the data science part, but it would also take a bit longer. Okay, so currently we are at the converge phase. It's installing all the Kubernetes prerequisites. You have access to the code, so please be free to go through the roles and check what it is doing. You can see here also. So here we, as I said, we specified a forwarded port. So we should be able to access our Kubernetes cluster. There is a cool feature on Visual Studio Code. So when you connect to another host via SSH Remote Explorer, you can forward the port from that machine. So here I have that port forwarded to my local host, and I can easily access it through any browser. Okay, so we can now SSH to our master with Vagrant SSH. And Kubernetes cluster should be up and running. kubectl get nodes, for example. Oh. Or is it? Oh, it's just initializing a Kubernetes master node. Should be good right now. Yeah. So we only have master nodes. Now it will go through Kubernetes workers playbook, where it joins workers to the cluster. Right now, that task is due. So there is a flag -w on Kubernetes, so you can follow a real-time update of your resources. We have a role Kubernetes install, which installs all the prerequisites that are needed to install Kubernetes and initialize master and workers. Then master, we install all the things needed for a master node. We initialize a Kubernetes cluster. On workers, we join those workers to the cluster. And in additional, we install some other dependencies like Calico. I don't know if you're familiar with Kubernetes. It's basically a container network interface. It configures a network for your containers and pods. Then we install Nginx ingress controller. So ingress controller is basically a reverse proxy that routes all the requests to specific services. Then we install local path provisioner, which provisions storage to our pods. All of this is a lot easier to do on cloud, because you don't need to do stuff like this. But yeah, the requirement was to do it on bare metal. So, and we install Helm here. Okay, so our workers and masters are ready. So we should we have our Airflow cluster namespace created. And we have our pods in Airflow cluster initializing. So again, we can. And okay, so now we can try and connect to our cluster. It's a self-signed certificate. Okay, so the service is temporary and unavailable. So when our web pod changes state to running one of one, we are going to be able to connect to our Airflow. And to fetch that password, so the password is automatically generated, dynamically generated, and stored in Kubernetes secret. You can specify what kind of a format you would like for when fetching secrets. It's base 46 encoded, so let's just do this. And we have our password. See how our pods are going. Okay, so our pods are running and we should be able to sign into Airflow. A default admin name for Airflow is Airflow, our password, and we're in. Okay. So remember when, so we specified test, Kubernetes deployment, destroy never. And fun thing is that you can specify each and every one of those steps you want to do. So let's say if we want to verify again some things. So we can do molecule verify -s Kubernetes deployment, and it would only run that step. And we can see that all assertions passed. And if when we are done with our manual testing or whatever we wanted to check manually, we can just destroy our instances with molecule destroy -s Kubernetes deployment. It will kill our SSH connection to the master. And we can see that all of our, not yet all of our instances are destroyed. Yeah. So to the data science project, where we actually deploy and test our data lake solution. I'll just run it now because it takes time. Okay, again, molecule test with scenario name. We have three scenarios, and we will use sensor deployment manual. So the first molecule test scenario, back office deployment. So what you can do when you specify multiple scenarios is in our case we have multiple services running on back office, and each service takes up some of the resources, and not all services are needed to test some sensor features. Yeah. So when what I'm going to is in different scenarios, you can include different roles and exclude some to, let's say, save up on resources that are needed somewhere else. So on the back office deployment, for example, here we are installing all the back office services and testing them. And on the sensor deployment, we have, for example, only one master node, 2 worker nodes, and 1 sensor. And we install only the services that we really need. And the difference between sensor deployment and sensor deployment manual is that on sensor deployment, we automatically provision one mission and test the integration automatically. And on the sensor deployment manual, we do not initialize a mission because we use it to test our, as I mentioned before, our shell scripts that use inventory file that we created and that call Ansible playbook as is. So also, so when you're testing some integrations that need authorization that you are not fine with putting in let's say Ansible Vault and in plain text somewhere, what you can do, you can use prompting. For example, we have LDAP integration for JupyterHub and Airflow. And to test that integration, we use prompting. So there is a thing called vars prompt, and it prompts you, for example, username and password, and you use that to verify LDAP configuration. So this is our molecule file for our data science project for sensor deployment manual test scenario. And we can see that we provision one master, 2 workers, and 1 sensor. Our master is a part of these groups, worker of these, and so on. And we are using quite a bit, a good chunk of memory and CPUs here. We also define a virtual network, private network, like in the demo that I showed you earlier. And we do some port forwarding. So this is a forwarded port on sensor for Kibana. You can see the default Kibana port here. And here we are port forwarding. So in our specification, we have put HA proxy in front of Nginx ingress controller. So this is a port forward to our HA proxy. Yeah. So, and also, yeah, in Converge, you can also specify from which playbook you want to import tasks from. For example, for our HA proxy role, we want to import only task from install. Okay, it's not because it's the only one. It's not the best option, but for example, here install backoffice Elasticsearch. We import multiple roles like install, create service accounts, and create Airflow connection. So we can do that also. So are there any questions? We have some time until our data lake is deployed. Or you would like me to show you something specific to... Okay, so for example, here in our prepare script, we transfer log files that we are parsing. So we can test our ingest pipelines, Elasticsearch ingest pipelines, our file bit configurations, and stuff like that. So everything is dynamically deployable. So our ingest pipelines, Elasticsearch data streams, index templates, everything is deployed based on mission ID. And when you deploy a mission, it's as easy to you just edit a configuration file, and currently it's deployed via CI/CD. So you update the configuration, and CI/CD creates a mission. From the back office side, you after it's deployed, you dynamically have access to all the data on that initialized mission. So you can query, actually not query, but search. You can search that remote cluster using cross-cluster search. You can use data replication. You can use everything. You can so the data scientist can log into JupyterHub and work on that data, create some visualizations. We have also there is also a visualization module that integrates with our module, which collects index template, and based on that index template, it creates some visualizations. So the data scientist can look at that visualizations, do some do some drilling down and stuff like that, and yeah. Okay, so we are finally on our converge step. We are currently installing HA proxy. Also, HA proxy and everything is Jinja templating is really good. Integration with Molecule and Jinja templating is really nice, and you can do lots of stuff. And for example, in HA proxy, we are so based on the number of master and worker nodes, we create different configurations. We have people ID, so HA proxy sends requests based on reliability, based on what servers is up and running responsive. Yeah, I don't know. I was looking forward to some questions, but so it takes some time, yeah. So no questions for me. So after this script is finished, we should be able to connect to our Kubernetes cluster and see that our services are up and running. We could connect to Elasticsearch and Kibana and see how our data is being processed using file bits. I don't know if you ever heard about file bits. It's basically a lightweight log stash. It parses logs and loads it to the Elasticsearch. There are plenty of configurations that can be done. You can also use ingest pipelines, Elasticsearch ingest pipelines. I can show you some, maybe some kind of ingest pipeline. So for example, here in sensor Elasticsearch deployment, we create mappings and ingest pipelines dynamically. So Zeek is basically a product that goes through pickup files or listens to an interface and creates log files. For example, and it delivers a specific set of predefined set of log files. But for example, here we can see some proprietary dissectors, so that are not that. So that need some specific filtering. I don't know if you heard about Elasticsearch ingest pipelines. What you can do basically there is process your logs, your messages. For example, here we know that input. So that message that we will get is in JSON format. There is a JSON processor that uses a string field message and converts it to a JSON structure with nested fields and everything. You specify a target field where you would like to store that parsed message. Then, for example, we have a dot expander, which then it expands those nested structures. And you can do all kinds of stuff, like you can even do painless scripting. So with painless script, it's something similar to JavaScript. So we can basically do anything, but they can't be too huge, because that isn't the idea behind it. So you can do all kinds of stuff, GeoIP enrichment, as we can see here, just in a second, and date format parsing. Okay, so here we can see GeoIP enrichment. You can it's using by default MMDB for its enrichment. And there are I don't know, four MMDB files that can be used. You can rename your fields. You can convert them to another type. You can do all kinds of stuff. Okay, so our instances are up and running, so we can connect to some of them. So we can see that our Airflow namespace is here, Elasticsearch in namespace, and that's currently it. So we have, I think that's it from what's going to be installed in this test scenario. Okay, so you can see that our Elasticsearch cluster pods are creating. We are using Elastic Cloud on Kubernetes. That's for deploying our Elasticsearch cluster. It's fairly easy to deploy Elasticsearch this way. So, okay, firstly, you'll need to install the Elastic Cloud on Kubernetes operator. And then it's fairly easy. So it would create a Elasticsearch operator. You just specify kind Elasticsearch and your Kubernetes specification here in Ansible. So we are using this Kubernetes core Kubernetes module, and yeah. You can do all kinds of stuff, volume mounts. We are using our local path provisioner to provision our storage to it. So we have resources request storage set to 50 gigabytes. But the thing is with local path provisioning is that you can't set like how would I say it? You can't set a limit. So it would provision the storage until it receives full capacity. The workaround behind this is basically to create a volume mount with your wanted a limit. And yeah. Then we create a Elasticsearch ingress. So ingress is what is used to gain access to Elasticsearch. Okay, so I canceled it because I forgot to do destroy never flag. So basically, it would destroy our instances after that. So because we are using the HA proxy, we need to. So I port forwarded to Vagrant at master, but then I need to. So we are using virtual IP address for HA proxy, and I don't have access to that virtual IP from outside the network. So I can. So I'm currently port forwarding from that to that from host to Vagrant at master 01, and then to that virtual IP address. And we are going to be able to access our Elasticsearch clusters and everything. Let me. For example, Kibana. So maybe I didn't port forward. Yeah, ports. Oh, where did my? Okay, just a second. It should be working. Okay, so to get to my point for manual testing, so what we now are able to do is to have our inventory file, and we can do Ansible, for example. Okay, have that set up. So this command is provisioning mission with mission ID 10-test with sensors being that sensor that we provisioned with Vagrant. We're setting Ansible user to Vagrant and specifying that it is for test purposes. Okay, let me check. Okay, this should work. I'll just connect to my master on another terminal and check if I can curl HTTPS this IP Kibana or Elastic. Okay, so this one is working. I'm listening to 443 and forking that to 443. That should be okay. And here we have hosts 8000 to 443. That should be okay. Interesting. Oh, sorry, didn't specify the port here. Oh my God. So, okay, so we have access to Kibana. This is Kibana on the back office. So when we provision our sensor, our FileBit containers will be deployed, our remote cluster will be deployed, and a remote cluster configuration would be set up also on the back office. So the thing is with remote cluster search is the only configuration you need to do is your remote clusters certificates need to be signed by the same certificate authority as the cluster you are trying to search it from. And then you just create a remote cluster configuration on the back office Elasticsearch, and you should be able to search through that data. So just let me get the password again. Okay, so these are all the users we created. And this is the password. There is a one-liner for this, but okay, so we have access to our Kibana. And we should be able to go to discover. Okay, so add integrations. Yeah, so it's creating a Kibana data view right now on the back office. Okay. And so we have our data views, and there is the data from remote cluster. So we can see the specification of this data view. So index pattern is this. So we have our remote cluster named like mission ID minus sensor ID. And with these wildcards, you can do all kinds of stuff. So when you are creating an index pattern for remote clusters, the main thing is this, I can't, dvotočka, between remote cluster name and indices name. So as we are using wildcards, we are currently searching through the data of all the sensors of the mission 10 test and through all the indices. And yeah, we have successfully deployed and so to test our to test our manual deployment test scenario, we can now do verify. So if we do molecule verify -s sensor deployment manual, it will then run our tests for the sensor and back office configuration. And yeah, so we can see here that all assertions passed and that everything is fine. So yeah, I mean, this is basically it, what I meant to show you today. Again, if there are any questions, you can feel free to ask me. And yes.
Thank you, Jakob, for this tutorial, and thanks to everyone who participated, and it was very interesting. Bye.
Yeah, thank you.